Hi, here's the group presentation from Chin Karki and Maniraj for Engineering Drawing and CAD for Course Assessment 3. First of all, I wanna give short introduction to Fusion 360 software. Is widely used for product design, engineering and prototyping, and also generate tool parts for manufacturing processes like CNC machining for manufacturing industry. And then for group assignment, our product is table fan that consists of 3 blades directly driven through a electric motor. Moreover, motor that moves blades that are attached to central rotating hub. Finally, the front and rear of the fan guards are made up of wire mesh which covers the blade from injuries.
For this assignment, our subject is a Panasonic table fan model AF30B, a 12 inches diameter table fan. So the goal is to recreate this table fan in Autodesk Fusion as realistic and as accurate as possible.
And next, here's the exploded view of table fan, and starts with front grill, then blade fastening nut that holds fan blade, and rear grill nut that holds rear grill, and main motor, and finally fan stand.
The animation of the exploded view, it shows how the fan is being assembled in the Autodesk Fusion.
Before start to sketch in AutoFusion 360, need to take measurement of rear unit. Here the example of measurements of rear grill nut. In the next slide, my partner will show how he recreate and sketch rear grill nut in Fusion 360.
So let me briefly introduce how I draw this fan assembly. Once we have taken the readings from the actual photos, we will try to do our best to replicate it in the system. So usually my habit is I will try to start it from the top, which means the top surface, and I will try to sketch out the overall dimension. There is actually dimension being defined here, as you can see. This is radius 18.75 and this is radius 18.75, diameter 35.7. So all of these are being predefined, and we'll extrude the overall shape. Up next, we'll try to draw the fillet out. Due to the constraint in Autodesk Fusion, it's not able to do fillet in a single direction, which means if I use the fillet function at here, this F, I can only create fillet at here, here, and here, not the other side. So I have to do it in the fillet way, not fillet, the sketching way on top of the surface. Then once extrude and merge again, it will create a very nice surface. No, not surface, a fillet area here. So I will try to create the writings on the real nut, indicates the direction of loose and tight, using the emboss function at here. Sorry, create emboss function. This function, it can emboss the writings out. This is how the writings are being created. Sorry, okay. So with this, just to make a better visibility. So at here, I try to create the with the wedge gear shape which is intentionally designed by the designer to increase the grip of the grill nut. So how do I draw it? I use the function of here, this one, pattern, circular pattern. So once I count how many gear is needed, I'm able to calculate. I'm able to save a lot of time and effort by drawing the gear. So once I draw the gear out, I can cut it just like this. And then I'm also making use of the function of tangent. So if we go into this sketch, you can see all of them are being defined. How to define is that here constraints, tangent or coincidence. So all of these are being defined properly. Up next, I try to round the edge here using a fillet function. So at here, this edge is being fillet properly to try my best to replicate the original part as much as possible. Then up next, last but not least, is behind at here. Try to create a shell surface here, and that's how we do it here. This one, the details here. So this is how we actually sketch this in Autodesk Alias. Of course, all of this is I use the vernier caliper to measure and try my best to replicate it as realistic as possible. So this is just one of the component, and up next, how do I actually assemble all of those parts that has been sketched together in the assembly is here. So design. This is how the part is being assembled together. So you can see it's being assembled one by one by drag and drop the unit from the taskbar here one by one and define them using assemble joint. And once you have to select the any round surface so that it can match conically in the center point. So I can do that like this, and all of the parts will join together. 2, 3, 4, 5, 6, 7, 8. So it comes to shape together. Okay, so at the end, this is an actual fan. I can also change the display of the fan. So this is a more realistic view without the edges. This is with the hidden edges, which means it's semi-transparent view. This is opaque view with edges. More and more, I can play around with the settings here. Like this is a dark sky, which makes it harder to view. I choose to go for photo booth. Usually, this is the easiest one. And up next, if I want to duplicate the simulation or animation, I go to the animation tab, because previously I've done this. It have a backup here, so usually it can be done by doing this, which means we can play around the timeline. And here front grill, how does it move? We can define it by transform, manual export, but just for your information, you can see this. So 1, 2, 3, 4, 5, 6. These two has not created a exploding view. Yes, let's try it. 2, 3, 4, 5, 6, 7, 8. So this is how I produce this project. Thank you very much.